Okay, this is lesson 8 of chapter 7. Today we are going to be learning how to use the r sine x plus alpha formula. Now the r sine x plus alpha formula, well, I've written a here because I can find an alpha, sine of x plus alpha formula is just one of a few different ones that you're going to see. So you're going to learn how to do plus and minus, or you should know how to by the end of the chapter, and also how to deal with Rcos of x minus alpha and plus alpha. It tends to be though that you deal with these ones because the primary values work really well with them. Right, let's get cracking. So we've got express 5 sine of x plus 12 cos of x in this form here. Now looking at this is annoying because you've got two different trig ratios in there. They're not combined. There's nothing really you can do with those. Neither of them is squared, so you can't try to turn one into the other using the year 1 formula. So it's a bit annoying, but we'd be able to get it into this form here, which is brilliant. It's really nice to have a form like that because essentially what that is you've got the sine of x graph, and then you've got a translation horizontal on it, okay, which is probably going to move it most of the time. It's going to move it left. And then you've got this thing, which is a vertical stretch. So you'll be able to express, you'll be able to draw this as just one trig wave, and you'll also be able to solve it really, really nicely. So you can take something that looks horrible like this and get it into something that's solvable, usable, drawable, which is absolutely great. And the way that we do it is by the use of the compound angles formula. Okay, now what we've got is we've got 5 sine of x plus 12 cos of x. We're aiming to get that to be r lots of sine of x plus alpha. Okay, alpha, I'm going to use alpha. Now that is the same as r lots of the compound angle formula for sine with a plus is going to be sine of x cos of alpha with a plus sine of alpha cos of x. Expand this out, you're going to end up with r sine of x cos of alpha plus r sine of alpha cos of x. Alright, so what we're saying is that this left hand side could be expressed as this right hand side. Now this is a bit annoying because what we've got is we've got a variable here which is r, and we've got a variable here which is alpha, and neither of which appear in this left hand side, so we're going to need to try to find out what r and alpha are. Okay, now we're going to actually do that, and it's really, really nice the way that it's done. So the first thing that we're going to do is we're going to have a go at trying to find out, well, what is the 5? Where does the 5 come into this side? Where does the 12 come into this side? And it comes in just by comparison. If you have a look at this term here, this r sine x cos alpha thing, you've got r and cos alpha with the sine x. Now that matches versus this thing, which is 5 with the sine x. Okay, you see the sine x part, you see the sine x part. And what you could do is you could say that 5 is equal to r cos of alpha. Okay, r multiplied by cos alpha comes out as 5. And also, similarly, here you've got 12, you've got cos x, cross those out, and you'll end up with 12 equals r sine alpha. Okay, so we've gone from having one long equation with two variables that we need to find out into two equations with two variables. Okay, now obviously these aren't linear, they've got curves and all sorts of stuff in them, and it wouldn't make any sense for us to try to, rearrange it and substitute it in. I'm sure it could work somehow, but I wouldn't really fancy it myself. What we can do though is I can say, well, if I want to find alpha, this is how it's done. Okay, to find alpha, I'm going to take r sine alpha equals 12, and I'm going to take r cos alpha, which equals 5, and I'm going to put the left over the left and the right over the right. Now if this is equal to this, and this is equal to this, then surely these two fractions must be the same. Okay, now the great thing about this is that the r's cancel, and sine alpha over cos alpha will be tan of alpha, and tan of alpha equals 12 over 5. Alpha equals tan to the negative 1 of 12 over 5. Alpha equals, and alpha equals comes out as 67.38 degrees. Okay, so that's finding alpha. Now, it's a bit weird, this method, because what you do is you deal with that, and that's totally separate from the next chunk. Often with maths, you do something and it leads on to the next bit, and it leads on to the next bit, and it leads on to the next bit. This is one chunk. You're going to see another chunk in just a second. Okay. Now, the other chunk, take these. I'll just draw a box around this stuff so you don't get confused with it. Take these, and we're going to have 5 squared, which is 25, equals r squared cos squared alpha. So I'm going to square both sides. You'll see why in just a sec. 144 equals r squared sine squared alpha. Now, these things are true. Okay, these things are true. If I add this r squared cos squared alpha to r squared sine squared alpha, that must equal the exact same answer as 25 plus 144. Okay, so I'm going to do that, and I'm also going to factor out the r squareds when I add them together. So I'm going to be adding this and factoring out the r squareds. So I'll have r squared, lots of cos squared alpha plus sine squared alpha equals 25 plus 144, which is 169. Now, from year 1, you should know that that is equal to 1. And so you'll find that r squared is equal to 169, which means that r is equal to plus or minus 13. But as r is greater than 0, therefore r is equal to 13. Okay? And so the form that we wanted was 13 sine of x plus 67.38. Okay? This here would give you the exact same graph as this here. Okay? We can know some other stuff about it. Instead of it being from 1 as its maximum and negative 1 as its minimum, it's going to go up by 13. So the maximum's up at 13 and the minimum's down by 13. That's nice to know. Okay, that's what that vertical stretch there at the start's doing with it. Okay, and also it's got a horizontal translation instead of it being centered where it would normally be, which would be at 0 where it would start. It's going to start at negative 67.38 and obviously carry on from there in 90s. So we've got 13 sine of x plus 67.38. So this question here, it's a bit wordy. Okay, you might want to pause the video and reword it, but I wanted to get it all on one slide, so it's a bit annoying. So sketch y equals the stuff that we just had. For x from 0 to 360, indicating coordinates of intersection with axes. That's actually one to watch out for, because a lot of people remember the x-axes but forget the y's, and we'll have a look at that in a sec. Indicating coordinates of stationary points being your maximums and your minimums. Use your graph to find out how many solutions exist of this thing equaling -1 between 0 and 360 degrees. Okay, so what we had from the previous slide was we had y equals, well, it'll be 13 sine of x plus 67.38. That's the thing that we just found out. And now I'm going to try and graph it, so I need to have the y equals, basically. Okay, now the first thing to know is that it's absolutely fine if you're moving things left by 67.38. You can have that left hand side, and you can always just get rid of it later if you want to. Okay, so for me, I've got 67.38. 0 take away 67.38 would be negative 67.38. Okay, and I know that with sine that'll be there. Okay, 90 take away 67.38 would be 22.62. Okay, 180 take away that number 67.38 would be 112.62. Another one, 202.62. And then we've got 292.62. Okay, now we know that it's going to go like that, then down, and then like that, and then back up again. Okay, so we'll go up like that there. Okay, so we'll go up, and then down, and then down, and then back up again, and remembering that it goes almost to the top, but not quite. Okay, I don't really need this side over here, so I can get rid of it. I could redraw it or something like that if I wanted to, but I'm just going to leave it on there. It's fine. Now the maximums are going to be at 13 and at negative 13. maximum at 13, minimum at negative 13. That's because of the vertical stretch here from that bit there. Okay, so we've got indicate the coordinates of intersection with the axes. Well, I've done that on the x-axis. That's fine. There's these two here, not that one there. Okay, but I haven't done it on the y-axis. Okay, well, the y-axis occurs when x equals 0. So y-intercept is when x equals 0. So we've got 13 sine of 67.38, which you could work out as a decimal. You could chuck it into your calculator or whatever else and find out what that is. Okay, and give the coordinate for it. For me, I'm just going to put it as 13 sine of 67.38, but a decimal is absolutely fine as well. Okay, your coordinates of your turning points. Well, your turning point there is 22.6213. Don't worry, you won't be asked anything where you've got to give this much detail very often, but I think it's useful for you to see it. 202.62 and negative 13, there's your next turning point. So we've got absolutely everything that we were asked for. Okay, I've got all my stationary points all sorted. It says use ugraph, it should say use your graph, to find out how many solutions exist of this thing equaling negative 1. Well, equaling negative 1 would be across like that there, okay, and it looks like there will be 2. Okay, just how many times does this line intersect with my original curve, which is once there and once there, so that should be 2. Okay, so this next question, it's no more difficult than the previous one. It's not got any of the sketch and it's not got any of that stuff that from the most recent slide, but I just wanted to give you a reminder about how to deal with the two cases that are involved in it. So just as a quick run through again, just in case you missed anything from the first one or I missed out anything in my explanations on the first one, we've got 5 sine of x plus 12 cos of x. Is trying to get it into this form, r cos of x minus b. Okay, that's going to be r cos of x minus b, which is going to be r lots of, well, cos of x minus b is going to be cos x cos b. If it's minus, then we're going to need a plus in there. Okay, plus r of sine x sine of b. Okay, by comparison, you can see that the cos thing matches against this cos thing, and so r cos b must equal 12. Okay, that's the cos x thing cancelling out, and we've got r sine b must equal 5. All right, so part 1, we'll do r sine of b. Always put the sine on top, because otherwise you'll end up with cot, and you don't really want to have to deal with the extra little bit of work in there. Equals 5 over 12. Okay, which means that tan of b is going to equal 5/12. Okay, which means that b comes out as 22.62. Okay, 22.62 for that one. Now, what's important to notice is 22.62. If you look to 22.62 and 67.38, they add up to 90, which is pretty interesting. It's one of the curves is shifting left and one of the curves is shifting right, which is why you really often deal with cos having the negative being there, all right, because it means it sort of shifts along, sine shifts along another way, okay, and they sort of shift along and meet each other. We'll also expect that r will be exactly the same. Okay, they should be the same regardless of whether you've got sine or cos, okay, or it will be the same. All right, part 2 was r squared cos squared b equals 144. And r squared sine squared b equals 25. Add the left to the left, add the right to the right, and we'll find out that r squared, lots of cos squared b plus sine squared b is equal to 169. R squared is equal to 169. R is equal to plus or minus 13. R is greater than 0, therefore R is equal to 13. And you get this graph here, which will be 13 cos of x minus 22.62, which will be identical. The graph will be absolutely identical to the sine version. Okay, hopefully those are okay. I think it's an interesting task. There's still a little bit more to do with these because we've got to learn how to solve, but I think that's enough for today's lesson. So your tasks: Edexcel Year 2 book, exercise 7E, which is on page 184. Questions 1, 2, 3 and 4 would do. 5 would be a nice extension. Give it a crack, take a picture, chuck it up on Google Classroom for me. Make sure that you've marked it before you do, and get in touch with any questions. Cheers, thank you very much.